Right, so let's take a look at section 4.1. Okay, I already kind of explained what the idea in this section is. You're going to be taking a sentence that's written using words. Okay, we're going to look for keywords like is, of, less than, some, all those kinds of things. And then we're going to try to take that and change it into algebra. All right? So, again, this is just explaining what we're doing. You just have to read that. So we're going to take a sentence that's in English. It's going to describe a relationship between two things.
Yeah, we don't have to write any of this down.
Two, sometimes, not as often, but there might be three. Okay, I think there's a couple problems at the end we'll do with three. All right, but in general, our sentence is going to compare two things. Okay, and our goal is going to be to write two algebraic expressions. Okay, so this is an algebraic expression, x minus 1. We had one we just did in the notes. What was it? 2x minus 7. Those were algebraic expressions you guys were just writing. So we're going to be writing two. Okay? Generally one for each thing that's described in the problem. If there are three things described, we will need to write three.
So on your notes, you have goal with a line with a blank. You're going to write two algebraic expressions, one for each quantity described in the problem. So you guys are going to write from there. I'm going to write it from here. All the way there we go.
And what we'll do is we're gonna work through an example together first. Okay, Mr. Roy and I have a template. We've used this kind of template before to help you kind of organize your thoughts and lead you through the problem step by step. All right, so we think this template's helpful, and what we'll do is we'll give you some on the test too. So the same template you practice with all week, we'll put the same one on the test so you're used to using it. All right. So as I mentioned earlier, we're not really going to solve anything today. Okay, at the end of this problem, we are not going to know how old Jack is. We're not going to know how old Paul is. We don't have enough information. Okay, that part's going to come tomorrow. For now, it's almost like we're just setting up an expression that we could use to figure out their ages if we knew a little bit more. Okay. All right, so first thing we want to do is we're going to pick a variable to represent one of the things we don't know. What's very important here is through the entire problem, we use one letter. Okay, so we're not going to use like J for Jack's age and P for Paul's age.
Hey guys, this isn't a step or anything like this. Like this is just the directions. Like if we ask you something like this on a test or on homework, that's what it'll say. Choose one variable to represent one unknown, then represent the other unknown in terms of that variable. So today, like Mr. Hager said, we're not solving any of these. We're not solving for a variable. All we're doing is setting them up. That's all we're doing today.
And we're going to give you some hints,
yeah,
okay, at how you do this. So the first thing you want to do is identify how many unknowns you have to find. Right? So if you read this problem, Jack's age is 1 year less than twice Paul's age. How many things are in that sentence that we could find? What are the two, or how many things are in that sentence? 2 things, 3 things? What do you think? About Ryan? Tell me something in that sentence you don't know.
Paul's age.
Sure, Paul's age. That's one thing you don't know. Is there anything else in that sentence we don't know? Victor? Jack's age. There we go. So in this particular problem, there are 2 things we don't know. Jack's age, Paul's age. Any question on that step?
Hey guys, the reason why you have like a template under every step is we're just going to show you step by step how to break it down. When we have you do it normally like on homework or on a test or something, you'll just have the one template to fill out. But we just want to show you step by step how it works.
All right, so step one. Mr. White, do they have these bullets or are they writing these in?
They have that all on there.
Oh, okay.
It's all on there.
All right, so step one. One of these two things, either this one or this one, is going to be represented by a single letter. Just a letter by itself. No plus anything, no minus anything, not times anything, just a single letter.
So guys, for this one, all right, what we want to do is, all right, we're going to come down. We have our template, all right? The first thing that we need to do is, what are the two things we have to find? All we're going to do, we're going to fill in our first column here with just what all we're going to do is just label it right now. So see where Mr. Hager highlighted right here. We have something highlighted here, something highlighted there. What are the two things that we have to find? We're not solving for anything. What are the two things we have to find? What's it asking us to find? Alexis? Exactly. So for step one, all I'm going to do is set up my label. So unknown 1 will be Jack's age. Unknown 2 will be Paul's age. So find anything below that. What's up? And for that first part, that's all we need to do.
And as Mr. Royce said, we've got a separate template for each step. When we go through a whole problem, you'll use the same template for the whole thing. We're just kind of breaking it out step by step, just for this one. Okay. Does everybody have Jack's age and Paul's age? Okay, that's the first thing you got to find. Okay, step 1B. Represent one of these unknowns as a single letter. Okay, and here's the really important hint. It's usually the one that's at the end of the sentence. Or as the way we wrote it here, it's written last. Okay, so if you go back up and read it again, Jack's age is 1 year less than twice Paul's age. Which one is at the end of the sentence? Jack's age or Paul's age? Which one? Yeah, a couple people said it. Paul's age. All right. So Paul's age is going to be the one that we represent as the single letter. All right. So from up above, we'd have Jack's age. We've got Paul's age. And we're going to represent Jack as the single, Paul as the single letter because Paul was the one at the end of the sentence. So what would be a good letter to represent Paul's age? Something that we could easily remember that this letter means Paul. Yeah, P. I would generally try to use the first letter of the person's name, unless their name begins with something that looks confusing, like if you had the name Lynn, all right, and began with an L. Be careful your L's don't look like ones and things like that. All right, so what did we decide on for Paul's age? How are we going to represent it? P. Okay, any question on that step? All right. You good, Ryan? You looking for? Okay. Right. Now step 1C. This is where we got to think a little bit.
Guys, on your sheet real quick, you got screwed up a little bit on your sheet. It says step 2B. Can you just cross it out and put 1C?
Okay, now we got to represent the other unknown, okay, in terms of the information that was given in the problem. Now, we're not going to use a different letter, okay? We're going to use P. Okay, we're going to use the same letter. Okay? And we wrote that right here. make sure you use the same letter. All right, so unknown 1, Jack's age. Okay, unknown 2, that was Paul's age. Paul's age we represented as P. Now we're going to represent Jack's age. Oops, let's bring this down a little bit. Okay, so let's go back up and let's read what the problem said again. Jack's age is 1 year less than twice Paul's age. Okay. How did we represent Paul's age? What letter? P. So I'm just going to just put that there so we remember that. Okay, let's start with this. Twice Paul's age. Okay, how would I represent just twice Paul's age? Yeah?
2p.
All right, so I'm going to start with that. I'm going to start with 2p. All right, so we'll put that in our box here. But now we got to be careful. What phrase in that sentence do we have to be very careful with? I said, watch out. Victor?
Less than.
Yeah, you got the less than. So we know what less than means. Victor, what does less than mean?
Subtraction.
Subtraction. So our two choices are, we've either got 1 minus 2p or 2p minus 1. Okay, but be careful with less than. Victor, you think you know it?
2p minus 1.
Nice. 2p, that's twice Paul's age. And when you see less than, what's at the beginning comes at the end. Okay, so 2p minus 1. Where are we? Here we go. And that's basically it. So we're going to kind of feel maybe like, wait, are we done? Well, yeah, for today we're done. We're never going to find out how old Jack is, how old Paul is. We'll never know. We're just setting this up. We'll actually find their ages tomorrow. Okay. Any question on that one? Okay, it takes a little practice to get used to, but I think once you guys get used to it, this template really helps, and it's the same steps every time. All right? So from now on, when we do it, we're not going to break it out into 3 templates.
Yeah.
We're going to use the same template for the whole problem.
Steps.
Yep. Okay. So does everybody have this? So basically, these are the answers I'm looking for on the test.
And guys, tomorrow, when we get into solving them, the template's going to be a little bit bigger. It's got a few more steps, obviously, because we have to solve. But today, all we're doing is filling in that first box. Like the first step, setting them up. That's all we're doing.
But what's nice is tomorrow's template is going to look similar. It's just going to build off of this one.
Yeah.
So most of it will look the same. It won't be that new. Okay. All right. Everybody got that? All right. So just some reminders, okay, about certain words and what they mean. Do you guys already have this on your sheet?
They don't have the words written.
Okay. What are some words that mean addition? What's something you'd see in a sentence and you're like, yep, I got to put a plus sign. Yep. Some. That's a good one. What else? Yep. More than. All right, so we got some, we got more than. What's another one? You could see add. Yep.
Product.
Product we're going to see somewhere else, but product is a good word for another one. How about increased by? All right, all those words. Some, we got that one. More than. Greater. If I said like 2 greater than x, that's like x plus 2. Okay, subtraction. What are some key words if you see them? You know it means subtract. In fact, we've seen one a lot today.
Less than.
Less than, and that's the tricky one. Less than is the one where the order switches. What else? Look at some of these words and basically just say the opposite of them. Yep. Decreased. Yep. So we got
Guys, this is on the back side of your note, if you're not sure.
less than, decreased. What do you call it when you subtract two numbers? You're finding the what? The difference. Yep. So we said decreased, we said less than, we said difference. Okay, and we're showing you an example here with less than. 2 less than Jeannie. You would not write 2 minus x. You got to switch it and put the 2 at the end. It's x minus 2. All right? So they switch places when you have the word less than. Fewer than. Okay, that's another one. All right. Multiplication. Somebody already said one of the words we use for multiplication. Rose, what did you say?
What? Oh, I said product.
Product. Yep.
Oh, it's confusing.
Okay, another word that means multiplication, we see this one a lot, very short word. Of, yeah. Anybody think of any other words that mean multiply? Product of. What's another way to say multiply? Times, yeah. Okay, I'll just add in product here. Twice. Okay, we saw that one in the last problem. Twice, was it twice Paul's age? 2 times P. Or 4 times Paul's age would be 4 times P. Okay, and then equals. Okay, for present tense, I can't think of a bunch of words that means equals. What's the one that we use the most? Is. All right. Yeah, we could see total. Okay, so there's a few, but not too many. Okay, I bet most of the time you're going to see the word is. Right, so this table's a good reference. If you get stuck and you're like, wait a minute, what does product mean? Is that multiply? Or you can use this as a reference. Go back and look at it.
You won't be able to use this on the test, right?
You can use, we're going to have your review sheet, and you'll be able to use that on the test. Yeah, your review sheet will have most of the important words you need to know. Yeah.
I always get some and
What's that?
I always get some and product mixed up. I don't know why.
Sum and product? Yeah, so there's a lot of different words. It's easy to mix them up.
I get them all mixed up.
Yeah. Now you can use that chart. Hopefully that'll help. All right. Does everybody have these important words? Good. All right. So let's work through. We'll do a couple together. I'll do a couple. Then Mr. Roy is going to do a couple, and then maybe we'll let you try one on your own, and we'll see how we're doing. All right. So let's just read through it. The larger of two numbers is twice the smaller. Okay. The larger of two numbers is twice the smaller. Write an algebraic representation for each number. Okay. In other words, do what we just did in the last problem. Okay, so here's our template. First, let's just decide how many unknowns are there in this problem. There's always going to be at least 2, but are there 3? Rose?
There's 2.
Yep, there's just 2.
Because it says 2 numbers.
Yeah, it does. It does. It's 2 numbers. Yep. What are we calling the 2 numbers here? What are they? What are the 2 words in the problem?
How they get said in the problem.
And they are on the board. They're described in the first sentence. Which one, Corey? Bigger? Yeah, what did they use? They didn't use bigger, but they used, yeah, larger. Okay, so we have larger and smaller. So those are my two unknowns. It doesn't matter which one you put where. Okay, so we've got the larger number and the smaller. Now, out of those two things, one of these is represented as a single letter. Okay? Where do we look in the sentence to find the one that gets the single letter, just a letter? That's it. Right?
At the end.
The one at the end. Perfect. Now, normally I would say just use the first letter of the word at the end. The only thing is I don't want that to look like the number 5. That's probably not a good idea. So when in doubt, what's a good letter to always use? X. X, that's not going to look like a number. Okay? So we identified the two unknowns. The one at the end of the sentence gets the single letter. Now we got to represent the larger one. Okay? Can I pick a new letter? Like, can I just use L? No. Make sure you use the same letter. So we're going to use X. Okay? Read it through. The larger of two numbers is twice the smaller. Okay? How did we represent smaller? What letter? X. How would you represent twice the smaller? That's what the larger one is. Twice the smaller. Victor?
2.
Like that?
Yeah, probably it'd be 2 x, right?
Yes. Perfect. The larger number is 2 times the smaller. And the smaller was x. That's it. Okay? We're not actually going to find what's the smaller number, what's the larger number. We don't know. That's all you have to do today. Okay? Any questions on the setup there? All right. Does everybody have that? Okay. Do you want? Let's do it. All right, so let's try this one. Mr. Roy is going to do this one with you guys.
All right. Scroll down here. All right. So guys, on up here, it's typed out. On yours, it's handwritten, but it's the same thing. All right. So we got Juan's age is 5 years more than Sarah's age. Write an algebraic expression for each of their ages. All right. So, Logan, what's gonna go here?
It's Tom Cruise.
Tom Cruise. So we got Juan's age is gonna go here. Juan's age there.
Mine's different.
All right. Is it different?
Yeah.
What's that? Example 2. Oh,
5 years more than 3 times.
that mistake is going to add it. So what you guys had, what you guys had was right.
Is that what you guys have now?
Okay, so we fixed it. So Juan's age first. All right. Gage, what's going to go here for unknown 2?
Sarah's age.
Sarah's age. Good. Davin, which one is going to get the single variable? Juan's age or Sarah's age? Why Sarah?
Oh, wait.
No, you're right with Sarah, but I'm asking you why. Guys, stop. Thank you. Huh? What do we say? Guys, someone help out Dad. What do we say the rule was? Anybody remember?
Use the same letter.
We're going to use the same letter. I agree with that. But why is Sarah going to get the single variable? Victor? Again, Davin, see how it's mentioned? It's the last thing in the sentence? All right? This second sentence doesn't really, it's just giving us the directions. This first sentence is where I get my information from. It's the last thing mentioned in that sentence. There's no information about it. All right? So because it's an S, let's just use X. We don't want it to look like a 5. All right? So Sarah's age will get the X. 99% of the time, guys, that's how it's going to work. And even if we get into like when we have 3 unknowns, you're going to see that at the end. That second thing, even though there's 3, the second thing is usually going to get the single variable. All right, so Sarah's age will just be X. So we use this. Now all I'm focused on is Juan's age is 5 years more than 3 times. All right, and everything we do is going to be based on that X. All right. So what I would suggest, guys, is work. Because even if whether you have like a decrease by or a minus or something like that, work backwards. All right. That way, if you do it the same way for an addition, if you have to set up like an addition, it'll be the same way for a subtraction kind of problem. All right. You guys all set in the back? Okay. Just making sure. So let's start with the second piece. 3 times Sarah's age. How would I show 3 times Sarah's age? Right. Like Corey just said, 3. All we know about Sarah's age right now, we always go back to that second unknown, is that it's X. So 3 times Sarah's age. I know it's hard to think of it that way, but that's what it's saying right now. Sarah's age is X right now. That's all we know. So it's 3X. All right, we covered that. Then it's 5 years more than. How do I show that, Kevin? 5 years more than. What's it? So we use this. We did this 3 times, right? What's another key term that we have up there? That's left. That's not crossed out. Huh? We're gonna need the 5 years. What's like? There's a word up there that translates to a math operation. More than, right? What's that mean, Kevin? What's that translate to? What's that become in algebra? What's more than mean? Plus sign, right? Addition. So I want to put my plus sign. Plus what, Kevin? No. 5? Right? We can't use the 3 times. We already used it. All right? So it's going to be more than 5. This is 3 times more than 5. That's all we have to do. There's nothing we can solve or anything like that. All we have to do is just set it up. So Juan's age, when I represent it, 3x plus 5. Sarah's age, because it's mentioned second, this is going to get a single variable, x. Right? Victor?
How come you wouldn't start with 1's age? Like, wouldn't you put like...
This is not, Victor, this is not wrong. If you did this, 5 years more than 3x, that works too. But if you had a less than, it wouldn't work that way. All right, because remember, less than, you have to put it second. All right, I'm just saying, sometimes it's good to work backwards, because if you have a less than, it's a subtraction problem, you won't make a mistake. If you get into the habit of doing that, you won't make a mistake. If you did it this way, if you know it's a more than, it doesn't matter the order you write it in, that's fine. But as soon as you see less than here, you got to know, okay, that's going to be the second part of the problem. All right? But if you think of it that way, Victor, 5 plus 3x, that's fine. But if this was less than, make sure you reverse that order. That's when things get switched. Okay? So either one is fine. All right? Good to move on with this one. Everybody okay out there? Davin, you all right? You alive?
Yeah.
Miss Bailey? All right, I'm going to the next one. Example 3. So that's in the bottom. As you're looking at your thing, your note sheet, bottom left. All right. The price of a book is $3 less than twice the price of a tape. Justin, what's my first My first unknown.
The price of book.
Book. I'm not going to put price of book. I'm just going to put book. All right. We're going to put book here. And Michaela, what's my second unknown? Tape, right? So book, if you put book price, you're not wrong. And I'm going to put tape right here. Mr. Nato, which one is going to get the single variable? Book or tape? Think about what we said in the last one. Dad, we talked about this on the last one, right? Which one's going to get the single variable?
Tape.
Why?
Because it's at the end.
It's at the end of the sentence, right? This doesn't matter. This is just telling me what to do. The first sentence is what I need, all right? And it says tape is the last thing mentioned. Tape goes as your second unknown. We can use T for that. That'll work, all right? We can use T. Put a little bit of a tail on it so we don't get mistaken for a plus sign, all right? So there's my T for tape. Now, this second problem that I set up, or the second thing I have to represent, the book. I know it's going to have multiplication in it. I know for sure it's going to have multiplication, right? Because of twice. What other math, based on what's there, what other math operation is it going to have, Victor? How do you know?
Less than.
Less than. Good, Victor. All right, Vic's on it. Less than means minus. So that means, what's that mean, Victor?
There's the reverse.
Right? Right, Ryan? Switching around. All right, so I'm going to put my minus sign. Put my minus sign right there. Caitlin, what's going to go after that minus sign?
2P. No, sorry, 2T.
I like 2T, but I don't like it there. I agree that twice the price of the tape is 2T. I agree with that. I just don't agree with where you put it.
Oh.
Should it go here or should it go here? Should it go in the beginning or the end?
At the end.
3
3.
here? Oh, okay. 3 goes here. I agree with that. And then what's going to go here, Caitlin?
2T.
2T. Because it's less than 3. It has to come second. All right, so it's, like Caitlin told us, twice. That means 2. We don't know twice the price of the tape. Right now the tape is T. So it's twice. All we know about the tape right now is it's T. 2T, because it's a less than, all right? Because it's a less than, that means subtraction. It's got to go as the second part. So minus 3. The only tricky ones, guys, if it's a more than or something like that, it doesn't matter how you do the order. You can put it any way you want, like we saw in the last example. But when it's less than, the order matters. You got to flip it around. I know I sound like a broken record up here, but Mr. Hager and I saw it all last year. You got to get in the habit of when it's less than, you got to put it second, right? What you'll do is you go through tomorrow especially, you go through all this work of setting up your problem, and then because you didn't label things correctly and write it down correctly in the right order, your whole problem's wrong. All right, so less than has to be second. All right? So you want me to do one more? I'll do one more. I'll do one more, then when I'm done I can pass out that second sheet. All right? I'll do one more with you guys. Do people feel like maybe looking at this problem? Let me read it through to you guys. The width of a rectangle is 8 centimeters less than twice the length. Write an algebraic expression for the width and the length. Take 5 seconds. Actually, I'll give you 10. Take 10 seconds, and I want you to write down the 2 unknowns. All right, take 10 seconds and write down the 2 unknowns. We'll work through this together. All right. Gabe, can you tell me what you put for unknown 1?
The length.
All right. You know, what did you have for your 2 unknowns?
Length and width.
Length and width. All right. The only thing I'm going to do, you're not wrong, but when we get into like representing what those things mean, it's easier if you write them in the order that they're given in the problem. Right? Width is first. I'm just going to show you it's a little bit easier if you put them in the order that it's written in. You're not wrong, but it's going to make your life a lot easier when you have to go through and represent them. So I'm going to put width first. Width's my first, and then, like Gabe said, I'm going to have length second. I got width, I got length. All right? Which one, Alex? Which one's going to get the single variable?
Length,
Length, how come?
because it comes last.
It's second, right? It's the last thing in the sentence. Like I said, this doesn't matter. This is just the directions. This gives us no information to set up that problem or represent it. It gives us nothing. All right? So length is going to be, I'm going to use X again. All right, I want you to take 20 seconds and figure out if you need to turn to your partner, go ahead. If you need to turn to the person sitting next to you, go ahead. I want you to figure out width. If you're not sure, you can ask someone sitting near you to figure it out. All right? Ariana, what'd you get?
I've got 2x minus
2x minus 8. All right? You said 2x minus 8?
8.
So I'm going to write one right here. 2x minus 8. That's what you said, right? Okay. Anybody? Victor? What's your vector, Victor? 2x minus 8. Anybody have anything different? Huh? Anybody have anything different?
I
Victor?
put 2L because of.
Oh, you use 2L? What I would do for just an L, Victor, is kind of make it like that, so it doesn't look like a 1. All right, so 2L, say the rest of it.
Minus 8.
Minus 8. Anybody, anything else? Justin?
I accidentally switched it. I did 8 minus 2x.
8 minus 2x. Anything else? Anybody else have anything out there? Anything else? Any other takers out there? Anybody brave enough to say what they wrote? All right? This, good. They both work. All right? I'm going to use 2x minus 8. Why Victor's fine. If he put 2L minus 8, he's good. Why wouldn't I use 2L minus 8? Alexis? I'd have X and L. I'd have 2 different variables. Make sure you use the same letter. But if you use length as L, Victor, and use the L up there, that's fine. But don't use L and X. That's not going to work. Justin, do you see why this doesn't work? Do you understand why? All right. What word is there in the problem? Someone tell me by raising their hand. What word is there that tells us we got to use, or what phrase is there that tells us we have to use subtraction? Ryan J. Less than. We caught that with you. You got it right. You're like, less than. You know it. All right. Less than. Right? What's the rule with less than, Ryan? Flip it, right? If it's less than, Justin, all right, we got to flip it. So less than, because if I put, this means that it's less than, this means negative 2x. We want a less than 8, so it's going to be minus 8, not minus 2x. Whenever it's less than, take the number that's in front of it, you're going to put minus whatever the number is that's in front of it. Minus whatever number's in front of it, and you're good. Again, less than. That's why we did so many less than, because they're so tricky. Right? If it's more than or something like that, those aren't bad, because the order doesn't matter. But when it's less than, minus, and then in the second part of your problem, minus whatever the number is in front of it. That's all you do for a less than. All right? Mr. H? I'll pass out that second sheet.
All right. So the last, we're going to do one more that's got 2 things in it. Then we'll try a couple with 3. Okay. This one's a little tricky. All right, so we're not going to have you guys do this one on your own. We're gonna help you through it. Okay? But that's the whole problem. This year, the price of a movie ticket increased by 1/5 of the price last year. Okay. First part's not too bad. Okay, all we have to do is identify the two unknowns. Anybody tell me what are the two things? What are the two things you don't know in this problem? The price when? This year and last year. Those are the two things we don't know. This year, last year. Okay. So we're going to start with that. So under unknown 1, put the first thing in the sentence. Okay. You could put price this year, but we're just trying to keep it short, so just put this year. Unknown 2 is the price last year. Right, so that's half of what we need to fill out. Which one of these two is going to get the single letter by itself? This year or last year? Kevin? Last year. You are correct. And why is it last year? Perfect. It's the one that's at the end of the sentence. I think for last year you could use L as long as you make it really look like an L and not a 1. All right. Now this is the trickiest one to fill out, the last one. This year. Okay. Anybody see a phrase in that first sentence that's going to tell us what operation we might want to use? There's a word in there there's a couple things going on, but I'm focusing on a certain one first. Yep. Yeah, increased by. What does that mean? Addition. Okay, so we're going to increase something. What are we increasing? We're increasing what? The price of the ticket. And what's the price of the ticket? Think of it as like, what's it starting at? What's the original price of the ticket? As a variable. Before the price goes up. Before the price went up, the price was L. So we're going to take the price this year, and what we're going to do, we're going to take what it was last year, and we're going to increase it. Did everyone see that? To get the price this year, we're going to take last year's price and we're going to increase it. But how much are we going to increase it by? Okay. That's this part of the sentence right here. We are going to increase it by 1/5 of last year's price. Any key word in that sentence? Of. What does of mean? Yeah, I put a little reminder up here. Of means multiply. All right, so we're going to get this year's price, take last year's price and increase it by 1/5 of last year's price. Anybody think they know what's going to go right here? Yeah? Yeah, perfect. If you can get that one, you can get any of them. That's a really hard one. Okay? So we got this year and we got last year. Last year was at the end of the sentence, so it got the single variable. So those three things were pretty easy. This top one I think was hard. All right? We saw increased by, so we wrote plus. Increase always means add. And what are we increasing? Well, you're starting with last year's price, and you're going to increase it. This is how much you increased it by. Right? And that's what I put the box around. We increased by 1/5 of last year. 1/5 times last year. All right, there's not really a simpler way that Mr. Roy and I could explain that one. That's a tricky one. Okay, so any question on that one? All right. So that's the last type we're going to do with 2. Okay. Next, we'll try 2 examples with 3, and that'll be it. But we're only going to do 2 more. Yep.
Would it be wrong if you, after the 1/5, you didn't put the L?
Nope, because it's addition. You could switch that order. You could write this. This is also correct. Yep.
What if you put L plus 1/5?
L plus 1/5 would be wrong
Right?
because it's 1/5 of last. So it's 1/5 times L. So we got to have that L next to 1/5. Yeah. Okay, any other questions on that one? All right, let's try this one. Okay, in fact, I'm not even going to look at the whole problem yet. I'm just going to look at that first sentence. Okay, it says the first side of a triangle is 3 times as long as the second. What are the 2 things in that sentence? Kind of like our 2 subjects. Yep. Yeah, first side and second side. All right, those are the 2 things. So let's just start by writing those down. Okay, don't even worry about this other sentence yet. Unknown 1, just put first side. Unknown 2, second side. So I'm going to start with that. All right. Now, let me read it again. The first side is 3 times as long as the second. What gets the single variable here? First side or second side? Second side. How come? Good. It's the one at the end of the sentence. Well, what's a good letter for second side? I don't really think S is the best choice. X, yeah, why don't we just use X? Okay, so we've got our second side. It's X. The first side is 3 times the second. So how would you represent the first side? It's 3 times the second. So think about what the second is, and then think about 3 times that. About Zach? How would you represent the first side? What is it? Read that to me. What does that say up there? The first side of the triangle, yeah.
The triangle is 3 times as long as the second.
Yeah. So the first side is 3 times the second.
Oh, multiply.
Yeah, 3 times the second. So what are you going to multiply? What 2 things? 3 times x. Okay? That's the first side. It's 3 times the second. So 3x. Okay, any question on that? So first side is 3 times the second. Now we got to read that last sentence. The third side is 5 centimeters shorter than the first. Okay. Well, first of all, we have a new unknown. What's my third unknown? Yeah? Third side. Okay, third side, that's like a new subject. We didn't have that before. Okay? All right, and now it says the third side is 5 centimeters shorter than the first. Do we have any kind of representation for the first side? How did we represent first side? Yeah? The first side is 3x. Okay, so what I'm going to do is just put that there to remind you. So all I really need to focus on here is 5 shorter than 3x. Or another way to say that would be 5 less than 3x. That's the third side. 5 less than 3x. Okay. Anybody think they could tell me what the third side would be? And keep in mind, we've got this phrase less than. Caitlin? 3x minus what? 3x minus 5. Does anybody think it should be the other way? 5 minus 3x. How come you switched the order? Why did you put the 5 at the end and the 3x at the beginning? Yeah, and what tells you to flip it? Yep, shorter than or less than tells us to flip it. That is correct. Okay. That's 5 centimeters shorter than the first side. So what's a little tricky about this, what happens if you messed up on the first side? What else would automatically be wrong? The third side. Okay, so you got to be careful when you write the first side, or you could get the third side wrong. Right? But those are the 3 answers I'd be looking for on the test. 3x, x, 3x minus 5. Okay, and again, it does take a little practice. Okay, so we'll try one more with 3, and I think that'll be it. All right. Any questions on this one? All right. Whenever you have 3 things, don't even look at the second sentence right away. It's just going to confuse you. Just read the first sentence. Bill has twice as many nickels than dimes. Bill has twice as many nickels than dimes. Okay, Alex, what's one thing I don't know in this sentence? Yep, I don't know nickels. Okay, and what's one other thing I don't know? Justin?
The amount of dimes.
The amount of dimes. Good job. All right, so I'm going to put those as unknown 1 and 2, nickels and dimes. Nickels, dimes. Okay, what's the next thing I need to decide? Mr. Roy and I have gone through about 6 or so with you, so hopefully you can tell us. Next thing I need to decide is what, Kevin? Yeah, I got to decide how I'm going to represent unknown 2, the one that gets the single letter. Good. Okay. Which one here is going to get the single letter? Maria? And then I'm going to ask why. How come? Yep, dimes. It's the one right at the end of the sentence. How do you want to represent dimes?
D.
Yeah, I think D is pretty good. We make a D. Right. Next, we got to go look at unknown 1, nickels. All right, let's read it. Bill has twice as many nickels than dimes. All right, so how do we represent nickels? The number of nickels he has is twice the number of dimes. 2 what? 2n. 2d. Why can't I use n? Yeah, make sure you use the same letter. All right. So what did we agree on? 2d. Okay. The number of nickels is twice the number of dimes. All right. Is there any more information I can get out of that first sentence? No, we're done with that. Okay. Now we got to read that sentence. Okay. He meaning Bill. Okay. He has 5 more quarters than nickels. Okay, wait a minute. Now they're talking about something else. Michaela, what's the third unknown here? Quarters. Okay, now we've just introduced quarters. Right? And let's read how many quarters he has. Okay, he has 5 more quarters than nickels. Right? So look at nickels. How about Justin? How many nickels do we have? It's not a number, but just an expression.
2D.
Yep, good job. Okay, so I'm just going to cross that out and write 2D. So we have 5 more quarters than 2D, or nickels. More. What operation is more, Victor?
Addition.
All right, so we're going to have addition. And we have 5 plus 2D. So what, yeah, Victor, what would that be?
5 plus.
Yeah. Is there any other way I could write it besides 5 plus 2D, and it would still be right?
2D plus 5.
You could also write 2D plus 5. All right, so 5 plus nickels, and nickels was 2D. Does everyone see how if we messed up on nickels, that would also mess up quarters? Okay, we got to make sure we get that one right. So those are the 3 answers I'd look for on the test. 2D, D, 5 plus 2D. Okay, we're not going to give you guys a lot with 3. Most of the time it'll have 2.
Is what, the last one, the homework tonight, guys, has 3.
Okay. So your homework tonight will be a worksheet on 4.1. And we'll also make sure we get that in the video. And we'll go over it first thing tomorrow.